So today I will tell you about the how we can find the bond order in 2 seconds. So first of all, you should write say numbering from 1 to 20. First series is 1 to 7 because 1 to 7 electrons the maximum bond order is 1. So first write 1 to 7 series. Okay. After write 1 to 7, then second series from 8 to 20, right here from 8 to 20 as an increasing order. Okay, so here we write from 1 to 7 series and from 8 to 20. Now what first of all 1 to series, so starting from here 0.5 add 0.5, so maximum is 1. So now what do you do? Subtract the 0.5. So here is 0.5, subtract 0.5, 0. Okay, now increase 0.5, 0.5, 1, and now maximum 1, so decrease 0.5, so 0.5. So here is the first 7. Now after that now right from here starting from the 0 here, so 0 here the bond order from 8 to 20 is 3. So 0, now you should need 0.5 add, so 0, 0.5, so 1.0, 1.5, 2.0, 2.5, here is a 3.0. So maximum 3.0 is a maximum. Now what happens 0.5 subtract, so 3.0 minus 0.5, so here is a 2.5, 2.5, 2.0, 2.0, okay, 1.5, 1.0, 0, 0.5, here's a 0. So what is this? This is the bond order. This is the bond order, and his counting here is a 1 to 7 and 8 to 20. This is the number of electrons. This is the number of electrons. So I took an example 1 to 7 simple. So we taken hydrogen H2. So H2, how many electrons in H2? In a single hydrogen, 1 electrons. Then here is 2 hydrogen, means 1 plus 1, there are 2 electrons. So here we shows that in the table the 2 has a bond order as a 1, means the hydrogen is a bond order 1. Easily if we here is a diatomic molecules having same diatomic molecules, hydrogen, oxygen double bond oxygen, nitrogen triple bond nitrogen. Here we easily directly we know that here is a one bond, there is a bond order will be the 1. Oxygen has a double bond, it's a pure double bond, therefore here is a 2 bond order. Nitrogen the pure bond, therefore here is a 3 order. Easily we can find if oxygen O2 have a plus 2, like, and take an example O2. So how we can find here is the bond order? So this is the trick, maybe works very fastly. So here is a O2 plus, it means 1 electron loses, therefore in 2 oxygens have 16 electron. 1 electron lose means 15 electrons. So here is a 15 electrons have bond order as a 2. So this way you can easily find out in 1 seconds. Taking another example, here is we take another example, carbon monoxide. So here is carbon monoxide having the electrons 6 carbon and 8, therefore 14, means bond order of the carbon monoxide is a 14, is a 3 bond order. Same as I am taking the lithium example, lithium Li2. So lithium is a one atom is a 3 electron, 3 plus 6 electrons. 6 electron as we show that bond order is a 1. Another example Li2 plus. So here is a 1 loose, therefore 1 loose means 5 electrons, 5 plus 0.5 order. So this trick maybe works after the diatomic different जो हमारे पास different. And now we're talking about the polyatomics. So polyatomics, how we can find out the bond order of the polyatomics? So there is a such tricks, you should need to write the formula. Bond order is equal to number of resonating structure, sorry resonating bond. resonating bond divided by number of resonating structure. Here organic compounds like carbonates, sulfates, so there is a polyatomic, so we can't find this trick. So we should, yeah, we should write from the here's different CO3 plus 2, CO3 plus 2. So how we can find the bond order of CO3 plus 2? So here, right here, sorry, minus 2. So here write structure of the carbon. So here carbon, double bonded oxygen, O minus and O minus. So this is the structure. How many possible structures, number of resonance? So here we can write this will be possible structure, and number 3, this will be possible structures. Means how many possible structures, resonating structures? So there are 3 resonating structures. And how many resonating bonds participates? Here is a 1 2 3 4. There are the 4 resonating bonds according to the formula bond order. How many resonating bonds? 4 divided by number of resonating structure. Here is the 3 number of resonating structure. So there is a 1.3333, so on bond order of this. So another easy trick, you how you can find the easily and how many resonating structures. So here is a surrounding atom. You should, here is a 3 surrounding atom, means the resonating structure will be the 3. Another example, SO4. Here is SO4 minus 2. So there is a 4, means resonating structure is a 4. So just write here the structure, only one structure, because we know that the 4 resonating structure. So this is the minus 1 minus 1. Now count the how many resonating bonds. 1 2 3 4 5, sorry, 1 2 3 4 5 6. There were 6 divided number of, here is a 4, means resonating structure 4. So this will be the 1.5 bond order. In this way you can easily find out. Take another example of the benzene. So here is the benzene, we write C6H6, but here is the difference because organic compound cyclic. So write down the structure from the hair. So this is the benzene structure, has a resonating structure. Benzene has 2 resonating structure, number 1 this and another this one. So means here is a resonating structure 2. Then how many resonating bonds? So here we should have only these pi electrons, this is pi bonds, this is the 3. So 3 divided by 2, therefore 1.5 bond order. Thanks for watching. If any question you may ask in comments or via email in the descriptions. If you are the new at my channel, you subscribe and share with friends. Never update my next chemistry videos. Thanks all of you watching.